Okay, section 8.8, difference of squares here. So today what we're going to do is we're going to factor binomials that are the difference of perfect squares and then solve equations involving those. So what we're talking about, look at the chapter, it's called difference of squares. So when we think about that, differences means minus or subtraction, right? And then squares means they're perfect squares. Perfect squares, so things you can take a square root of. Okay? So if we look at our, just jump right down to our first example here, x squared minus 25. So I'm going to use the square method here to do this one, just to kind of review that as well. But if you take this, make our squares, I should say. Remember, the first term goes in the upper left. The last term goes in the bottom right. Okay? And so when we think about that, we know that just off the hand, what makes x squared would be x times x, is those factors. And 25, if we're looking at how we get that, we could take 5 and 5, but one of them's got to be positive, one's got to be negative. So if we put a 5 here and a negative 5 here, then when we do the math in the middle, when we multiply, we would get negative 5x here, and we get a positive 5x here. And because when we multiply, or when we add those up, we end up getting a 0x, which is what we want. Because if you think about this, what's missing here is the middle term. If you were to write this out with a b term, it'd be x squared plus 0x minus 25. So that is what we want, is this 0x here, and that's what we get when you have plus 5 and minus 5. So then our factors are good to go. And so we would basically be looking at, here is, remember there's no sign, we'd say, oops, there's no sign, we would say plus 5, okay? And here's a negative 5. So our factors are right here and right here. So we'd simply say the answer to this one, the factors would be x plus 5, x minus 5. So you're going to kind of see it's like the backwards of those shortcut problems we did, where we've got one is positive, one is negative, and that's going to make the middle term disappear, which is why it's at 0 here. Okay, so kind of what's the pattern? What are we looking at here? Well, we know for a fact that A and C are perfect squares. Okay, so if you look at this one here, the second one, x squared is perfect square, 9 is a perfect square, because its square root is 3. Over here, x squared is a perfect square, 81 is a perfect square, square root is 9. Okay, what's the other pattern? Oops.
Can I please get a custodian to the school store, the hallway by the school store?
Okay, someone might have barfed in the hallway there. I need a custodian, sorry about that one. Okay, so what we want to do here then is we want to take the square root of both terms for the factors. Okay, but we also notice what else is the pattern is that there's a minus in between. Let's just check that. Okay, so the other thing we have is that there is a minus sign or subtraction sign in between. So that's basically the pattern here. We've got A and C are perfect squares, and there's a minus sign in between. Minus sign in between. So if you got that, then we're in good shape. Okay, so let's look at what we call, it's called a difference of squares. So this is where we would say a squared minus b squared equals a plus b, a minus b when you factor it, right? So let's take a look at an example here. If we had, say, 4x squared minus 81, okay? Again, we have perfect squares because we know this is a perfect square because I can take the square root of it. Square root of 4x squared would give us 2x. And then this one is also a perfect square because the square root of 81 equals 9. So if you can take the square root of both terms to the factors, that's this part here. If you can do it and get an even number, then or a whole number, then you're in good shape. Okay? So now what we have is basically the 2x goes first in both parentheses. The 9 goes second in both parentheses. And because of this minus sign here, then we have one has to be positive and one has to be negative. Okay? And that's it. Because notice here's the positive and negative here. All right, so let's look at our next stuff here. Let's to factor a difference of squares. So the first thing we're going to do, and we'll kind of work through an example as we go through this, but the first one, factor out a GCF if possible. So let's do an example where we have a GCF that we have to work with. So 2x squared minus 32, okay? So if we can factor out a GCF, then that's great. So let's do that. Both these terms have 2 in common. 2 is the only thing that's in common there. So if I factor out a GCF of 2, I'm going to be left with x squared minus 16 in parentheses when I factor it. Okay? Well, the next step says to determine the square root of a and c. So do we have perfect squares here? Yeah, we sure do. The square root of a is x. The square root of c here is 4. Square root of x squared is x. Square root of 16 is 4. And we've got the minus sign in the middle, so we know we're good to go. So what we want to do next, the next step would be rewrite in factored form in parentheses. So we rewrite that. Remember, we need x plus 4 and then x minus 4. One has to be positive, one has to be negative, so that it'll get rid of that parentheses. Okay? Don't forget your 2, though, because this 2 came along with it, so it has to come along with it. Okay? You can't just leave that 2 out. And finally, we're going to check to see if the factors can be factored again. Can they be factored again? In this case, they can't. So if you have to, we have factor some more. In this case, they can't be. So if you have to group in pairs, remember if there's 4 terms. Okay, so those are kind of your step-by-step stuff there. All right, so let's take a look at an example, shall we? All right, the first one looks a little bit tricky, but it's not. So we have to kind of look, can we factor out a GCF? Well, no, there's not really anything in common there. Greatest common factor. It looks like it's already set. So determine if there's square roots. Well, we know that the square root of this one here is x, because the square root of x squared is x. But what about this one? This is a perfect square, because if you just take them at their own, top and bottom, numerator, denominator, they are perfect squares. This one would be 6. This one would be 7. So really, we'd have x as our square root here and 6/7 here. So we could rewrite that x plus 6/7 times x minus 6/7. Or one has to be positive, one has to be negative, because that'll cancel out that middle term, that b term. Okay. Let's skip number 2. Let's look at number 3. Number 3, what do we notice about that one? We have perfect squares. Yep, we have perfect squares, but we don't have a minus sign in between. We have a plus sign, so we can't factor that as a difference of squares. Okay, that one can't be. All right, and let's skip down now to, we can do these other examples if you like. I think you can get the hang of it. Let's talk about when we solve equations. So it's kind of like everything else we did before. When we solve equations, you're going to eventually set it equal to 0. So first step, as usual, we're going to get all terms on one side of the equation and set it equal to 0. Okay, that's the big factor there. Make sure we put that in there, that we're setting it equal to 0. Factor out a GCF if possible. That's the same thing we did before. And factor any which way. If you want to use your strategies, go for it. And then you want to set each factor to parentheses equal to 0. So set each factor, whatever you have in parentheses here, set that equal to 0 and solve. So it's just like we did in section 8.5c and also again in 8.7b. And then we want to write our answers in set notation. And of course, then you can always check your solutions to make sure that you have the right answers. Okay? So let's do some examples of this. All right, we'll do a quick one, and then we'll do a long one. Okay? One that looks a little tricky. So let's look at number 1. Number 1 should be an easy, quick one for us. So if I look at it, I don't have to factor out a GCF. I'm in good shape there. Everything is on, first step, everything's on one side of the equation. We've got it equal to 0. That's good. Okay? And then we don't have any GCF to factor out. So let's go ahead and determine the square root, factor this thing. So this looks like a difference of squares because I know this, the square root of that is x. I know the square root of 49 is 7. So I can simply go ahead and write, factor this into x minus 7, x plus 7. That order does not matter. Just one has to be positive, one has to be negative. And then from there, now I'm going to solve. And then we're going to take each little piece of parenthesis, each factor, each parenthesis, and set it equal to 0. And then I'm going to solve. So I know here, if I add 7 to both sides, I'm going to get x equals 7. Over here, I have to subtract 7 from each side, so x would equal a negative 7. And then the final thing is I got to put it in set notation. So to do that, I make my little brackets. And you can get kind of lazy with this one because it's positive negative 7 and just write positive negative 7. That works. Okay, positive negative 7. Okay, let's do one. Let's skip 2. Let's go for a long one here, number 3, one that we got to go through all steps. So the first thing says, let's get all terms on one side of the equation. So to do that, we're going to subtract this 3y from each side. So that's going to give us a 48y cubed minus 3y equals 0. So now we've taken care of step 1. Get everything on one side, set it equal to 0. Do we have a GCF we can factor out here? Well, we got 48y cubed. We've also got 3y squared. So I think we can take out a 3y here. I think that's what we can factor. They have that in common. So if I take out a 3y, then what I'm left with inside is 16y squared, because 3y times 16y squared.
Jacob Lewis, please report to the main office.
Because 3y squared, or 3y times 16y squared would give us 48y cubed. All right, now, and then I have a minus 1 on this side, all equal to 0. Okay, so now what I'm looking at doing is, do I have perfect squares now? Can I factor this out? Sure thing. Don't forget to bring your 3y down. Don't forget to bring that down. That's going to stay with us. But I can use this as a difference of squares because the square root of 16y squared would be 4y. Take that over here. The square root of that would be 4y, because 4y times 4y would be 16y squared. And also, we would know that right here, 1 square root of 1 is 1, so it is a perfect square. So when I factor this out, I can go 4y plus 1 times 4y minus 1. And don't forget to keep it equal to 0. So now I kind of have 3 things, and that's where we look at it's 48y cubed here. Okay? So I got 3 different y's to deal with, 3 different factors. I've got this one of 3y. I've got this one of 4y plus 1. And I've got this one of 4y minus 1. So when we set it to equal to 0 here, we've got to do 3 of them. We've got to do 3 of them. Okay? So the first one, we're going to go 3y equals 0. Over here, I would go 4y plus 1 equals 0. And then I'd have 4y minus 1 equals 0. So let's go ahead and solve these. If on this one, we know I would just have to divide by 3. So y would equal 0. Over here, I'd have to subtract 1 first, then divide by 4. So I'd have y equals negative 1/4. And on this one, I'd have to add 1 to each side first, and then divide by 4 to get y equals a positive 1/4. So the last thing, I have my answers. I just got to set them in set notation. So to do that, I'm just going to say, here's my bracket, 0, and I've got a positive negative 1/4. And there's my other bracket. And I'm good to go. Okay? So that takes us to the lesson summary here. What is one important thing to remember when factoring the differences of perfect squares? So we gave you a bunch of stuff to think about. What's one important thing you're going to have to remember there? And then finally, we want to solve this one. X squared equals 1/9. Let's make sure we factor that first. And there's something different here that we have to deal with, so make sure we factor it first, then solve. But we're going to have to set this thing equal to 0. So make sure we move that 1/9 over. Okay? That does it for 8.8. We only got one section left. We'll see you tomorrow.